Let's do some homework. Let's focus on problem 1. Find the general solutions of the given systems. Write your system in the form x equals c1 x1 plus c2 x2 plus ... That is in a linear combination. So let's rewrite this system in matrix form. So I'm going to say x prime, y prime on the left-hand side of the equal sign. And then here I'm going to write x plus 2y, but I don't want to put the plus. I'll just put 2. So if I want to write it in matrix form, I see that the x coefficient is 1 and the y coefficient is 2 for this top equation. And then for the bottom, it's 4 and 3. Then I write here x and y. Close this. And now what I do is I try to solve it. So to solve this is a homogeneous system, because I recognize it because this is my A, this is my, let's say, x vector, and this is my x prime vector. So this is a homogeneous system. Homogeneous or homogeneous system. So I can solve it with the eigenvalue problem. So that is going to be 1 minus lambda, 2, 4, 3 minus lambda. Close this. Here we're going to have k1, k2. Close this. Equals to 0, 0. Okay. So now I'm going to find the determinant of this first matrix, which is going to be, if I factor out a negative sign, this and this minus 2 times 4 equals 0. So first thing I notice is that the negatives here cancel. Then I can expand this as L squared. The sum of the two is going to be negative 4 lambda, and their product is going to be positive 3, and then we have a negative 8, and all of that is equal to 0. So now we get lambda squared minus 4 lambda minus 5 equals 0. Now can we think of two numbers, and I'm going to move myself over here. Can we think of two numbers that multiplied together are equal to negative 5 and added together are equal to negative 4? I think negative 5 and 1. So lambda minus 5 and lambda plus 1, their product is negative 5, their sum is negative 4, are equal to 0. Okay? So now I can say that lambda 1 is equal to 5, and that lambda 2 is equal to negative 1. And once I have this, what do I want to do? Well, now I want to substitute it back in. So for lambda 1 equals 5, what am I going to do? I'm going to have 1 minus 5, which is negative 4. So here I'm going to have negative 4. 2 and 4, so 2 and 4. And then 3 minus, this is a minus, 3 minus 5, that's negative 2. And now I notice that the rows are dependent, which hints that I am doing fine so far. And this is the eigenvalue problem. Now I'm going to use the top row, plus 2k2 equals 0. Or in other words, I can say negative 4k1 is equal to negative 2k2, or k1 is equal to if I divide both sides by -4, 1/2 k2. So if I let k2 be 1, k1, well, let's make a k2 be 2 so that we take away the fraction. So now we have our k vector, our first one is the vector 1, 2. Okay, so now we have to do a similar thing. We have to do it for, I wanted to do it black, or yeah, black. Now we have to do a similar thing for lambda 5. So for lambda 2, which has a value of -1. So now we're going to look at the matrix that we have. The original matrix, we have 1 minus -1, which is 2. So here we're going to have a 2. And then on the other diagonal is going to have 3 minus -1, which is 3 plus 1, which is 4. And then the other two entries will stay the same. So that was a 2, and this one was a 4. I notice again that the rows are dependent, which is good for us. Dependent. K2. Close that. And that's going to be, you'd probably want to call this K3 and K4. And that's going to be 0, 0. And so now I'm just going to use the top one, K3 plus 2 K4 equals 0. And so now what? Now I can say that K3 is equal to the negative K4. Or let's say that K4, so let K4 be equal to, okay, actually I missed a step. No, I didn't miss a step. My bad. K4 is equal to 1, then K3 is equal to -1. So we can say that our K2 vector is equal to -1, 1. So now we can say that our general solution, we have a 2 by 2, so we only need 2, is going to be, so we can say that x1 is going to be 1, 2 times e to the eigenvalue for this one, which was 5t, and x2 is going to be -1, 1, as you see right here, times e to the value for this lambda, which was -1 times t. The complementary solution, they're asking for the general solution. You can say that that's the linear combination of the first solution and the second solution, which we can write over here. So we can say that x as a function of time is equal to 1 and 2 e to the 5t plus -1 and 1 e to the -t. Now, don't forget, you got your constants here. They even tell you. And this is going to be your part A. I'll see you for part B.